Hey Crimson team, there's a couple things need to review for the science test on plate tectonics coming up in a couple days. The first thing we're going to talk about in this little video is layers of the Earth, convection currents, and Pangea. All this stuff should be in your journal, so you should be okay. You should be able to find material that goes along with this. When we first started the unit, we talked about how do the geologists actually figure out about the layers of the Earth. We can't just dig a hole to the center of the Earth. It's far too deep, as well as it gets hotter the further you go in and the pressure increases. So there's no way that we can just dig a big hole. So we talked about direct and indirect evidence that geologists used. The direct evidence is from actually drilling samples. So we do actually use evidence from rock samples. But again, that only goes so far. How do we find out about inside the Earth? Deeper inside the Earth. We talked about seismic waves. We did a quick experiment using a pie plate and water, and we made little waves with our fingers, and the waves went off the side of the pan and back to the middle. And then we put a cup in the middle of the pie plate and made little waves with our fingers. And this time the waves went around the cup because there was something in their way. We compared that to how the geologists use the seismic waves in the layers of the Earth. Sometimes the waves go through a layer, sometimes they're going to bounce off a layer. The reason why they bounce off is because the layers are made up of different materials, and that's how they can infer how that there are different layers of the Earth. Again, the direct evidence is from rock samples, and the indirect evidence is from seismic waves. After that, we talked about gobstoppers being like the layers of the Earth. And more specifically, I want you guys to remember the different layers that there are. Starting from the inside, you have the inner core, the outer core, the mantle, and the crust. And from there, we went on to talk about the asthenosphere and the lithosphere. If you remember, the asthenosphere was unique in that it was flexible, just like an airhead. And when we talk about convection currents and the plates moving, that's really important that the asthenosphere is actually flexible. Right above the asthenosphere is the lithosphere, and the lithosphere is made up of continental and oceanic crust. The continents that we stand on and the ocean are the two parts of the lithosphere. A way to remember it is LA, La. Lithosphere is above the asthenosphere. After that, we talked about the convection currents. If you remember, I did a demonstration with the fish tank, and I took a can of Diet Coke and stuck it in the water, and the Coke sank and the Diet Coke floated, and we said that was due to density. How much stuff was in the Coke? The Coke had more sugar, so it sank or was denser, and the Diet Coke had less sugar, or it had a sugar substitute, so it floated. It was less dense. We then put some dye in cold water, and we had a pie plate with the hot water, and we watched the blue dye form a convection current in the pan. So again, as far as the layers of the Earth, the hot parts of the layers rise, and the cooler parts sink and rise and sink because the heat of the core is actually driving the convection currents in the layers of the Earth. So if the convection currents are moving, it's going to cause the asthenosphere, which is flexible like an airhead, to move. And on top of the asthenosphere, we said, are the seas and the land, or the oceanic and continental crust. And that's why plates are able to move. We also talked about evidence from Wegener's hypothesis to support his idea about continental drift, that the continents and oceans actually move, the plates. The evidence included land features, fossils, and climate change. The theory that the continents were once joined together in a single landmass and have since drifted apart is the theory of continental drift. And the landmass was known as Pangea.